So let's continue our analysis of the torque slip characteristics. The expression is given Tm is this. So we have discussed in the previous video and I have explained how it works. And then this is the characteristic, this is the shape of the characteristic. As initially the load torque increases, the slip increases, and then finally this is the starting torque and all. So this is how the characteristics looks like. Now in this point is the maximum torque point. So, and this is the starting torque point, and then any point, like for example, this is the operating point. So, in fact, this is the operating region of the induction motor. Induction motor cannot operate in this region because the torque is reducing for the reduction in the speed. So therefore, this is not stable operation. It will operate on this side. Now let's continue our study. So what I want to do in this is derive a condition for maximum torque. Okay, so let's do that. I think I've already done this once, but then let's quickly do it. So as you know, torque is 3 by 2 pi ns, and then S into E2 square R2 divided by R2 square plus S x2 whole square. Now I want to find the maximum value of this. Okay, so how to find the maximum value? Simply differentiate it and equate it to 0. Here the variable for differentiation I am taking slip. Okay, so this is constant, so this term is constant. E2 is constant for the time being, so only variable is SR2 and all these things. So I'm just writing this as a constant, 3E2 square divided by 2 pi ns. This is multiplied by S into R2. So for the time being, I think even I can bring this R2 outside. So only thing is remaining here is S, and then multiplied by 1 by R2 square plus Sx2 square. Okay. So this is a constant, this is function in S, this is another function in S. So let's differentiate it. So if this is nothing but, I still not applied the differentiation. So I'll say this needs to be differentiated. I'll just put a dash. So differentiation of this. Now UV rule, you know, differentiation of UV is U dV into, sorry, plus V du. Okay, so that's what we'll apply here. This is constant. So the constant, I'll just put it like this, 3 to square R2 by 2 pi ns. Now this multiplied, so differentiation of S is 1, and this term will come as it is, product R2 square plus Sx2 whole square. Now plus differentiation, the S is as it is, and now I want to differentiate this term. So 1 by something differentiation, it will become, uh, first it will have a minus 1, and then in the denominator it will become a square. Again there will be a whole square. Okay. This is 1, and then differentiation of, see, because in the denominator there is a, this is constant, so differentiation of this is 0. I have to differentiate this Sx2 square. Okay, so effectively it is x2 square into s square. So the differentiation of that will be 2sx2 square. Okay. So I got something like this. Now this should be equal to 0. Okay. So something multiplied by something equal to 0. Since this is a constant, I can just simply ignore this term. And then since this minus is there, so let me simplify that. So I take it to the other side, and then here there is a minus, or I'll keep this term here, R2 square plus Sx2 square. So this minus will multiply with this plus and will become minus, and then it goes to the other side. So then again it becomes plus. So I have 2s square x2 square divided by R2 square plus Sx2 square whole square. Okay. Now on either side, this is, I can just cancel out this with 1 power. then this will go here and multiply. So I get a simple expression like R2 square plus Sx2 whole square equal to 2 into Sx2 whole square. So this term I can cancel out from here and I can remove 2. So finally I get R2 square equal to Sx2 whole square, or R2 square equal to S square by X2 square, or this implies that S equal to R2 by X2. So this one is the condition for maximum torque.
It's 4 o'clock.
Okay, so this is the condition for maximum torque. So when the slip is equal to R2 by X2, I get maximum torque. Okay. So now let's actually find what is maximum torque. Okay. So what is maximum torque? I think I'll do that in the next video. We'll just continue it to find the maximum torque. So here we have just derived the condition for maximum torque.